Hi there, and welcome to my channel. My name is Shivangi, and I'm excited to be your guide into the world of data science. Now, if this is your first time on my channel, the Thrive Tribe is a community which is for the people who want to achieve the goals that they set for themselves. If your goal is learning about data science or any skill, or for that matter, picking up a new hobby, exploring a new sport, so then this is the community to join. Now, with that being said, let's move ahead and look at the ABCs of data science. This video is the first in series of videos to follow for beginners to see what the world of data science looks like. What is data science and why is it important? You see, when we were growing up, we didn't really hear a lot about data science, but now suddenly this is all everybody's talking about. Why is everyone talking about data science? Why is it important? You might wonder. Well, data science is a study of data, self explanatory, right? And you're just trying to extract meaningful insight from data. Now, the reason it became so important is because you see the way technology has evolved in the last couple of years, both our ability to generate as well as process data has increased a lot. So obviously there was this need to use this data and then somehow convert it into insights which can be used by researchers or let's say the businesses, corporates, for them to target the audience, to deliver the products better, to increase the accuracy of their measures. So data science is going to be a multidisciplinary approach. There's a multidisciplinary approach involved here, which means that you would need to learn statistics, you would need computer programming, and for that matter, even sometimes domain expertise. Dealing with financial data would require you to know about those financial ratios, right? So you would also need those domain experts. Now, with this analysis, what you're trying to do is answer four fundamental questions. These are the four kinds of analysis that are usually done. The first is descriptive analysis, where you find what happened. Through the data, you analyze what happened. You can jump onto the diagnostic analysis, where you also find not just what happened, but also why it happened, right? Then there are predictive analysis using forecasting, trend and time series analysis, where you also look at the probability of what will happen, the likelihood of something happening. And then there is the prescriptive analysis, the most advanced kind, where you look at all of these and also tell what can be done with all of these results, how to, let's say, ensure an event happens or doesn't happen. So that kind of analysis is called prescriptive analysis. Now, there is so much data around, as I said, right? You might wonder, is all the data same? You see, data can be categorized into qualitative and quantitative type. Now, qualitative data, self-explanatory, is telling about the quality of something, right? And quantitative data looks like something you can count. You're right. Qualitative data, however, is split into two main types, the nominal data and the ordinal data. Now, I'll give you a quick example. Let's say you conducted a survey where the first question was, what is the color of your hair? And the second question was, how would you rate this survey? All right. Now, both of them, in both of these cases, you are taking qualitative values from your customers. So in the first case, your customer is likely to enter brown hair, black hair, red hair, maybe silver, yeah, different colors. But there is no inherent order in these. You cannot say that brown is better than black and black is better than green and so on and so forth. So there is no order. They're all labels, but there is no order. Whereas in ordinal data, the feedback that you took, right? So there could be options like very good, good, average, not so good. So they are qualitative labels, but there is an order to them. So obviously, if somebody is rating very good, that means they had a better experience than somebody rating good, than somebody rating average, and so on. So although you're taking qualitative values in that attribute, it could be nominal or ordinal basis if they inherently carry an order. Coming to quantitative, there can be discrete values and continuous values. Now, discrete value simply means something that you can count. I mean, the possibilities are countable, finite. Let's say the students in a class can be 29, can be 30, cannot be 29.01, right? But in continuous data, your variable can take infinitely possible values. For example, your variable is temperature. Now, temperature can be 101, 101.01, 101.02, and so on. So there are infinite number of probable values that can occur. And that is your continuous data. Now, in the coming videos where I'll talk about data visualization, I will show you 4 different data sets and how are they visualized? How does nominal data look? Ordinal data? What is the right visualization technique for these data kinds? Now, what does a data scientist do with all of this data? I'll just give you a quick peek of the processes, and then maybe in the coming videos, we'll have an elaborate discussion on each of these. So a data scientist reads the data, gets it on system. That's a very good habit to first have a glance at the data, because here comes the big step, which is preparation of your data. You might wonder, what is preparing data? I mean, data comes prepared, right? This step right here is what is going to take a lot of your time. You see that in an ideal world, yes, the data you would get would be absolutely clean and you would love it. But in reality, there are a lot of missing values, junk values. There could be incorrect entries, missing numbers, or let's say some duplicates, which might affect your analysis. So in this stage, you need to work on your data, ensure that you clean it in the best way possible, because there's a saying in data science that junk in, junk out. So if you're building a model, if you put junk into the system, you will generate junk out of it. So it's extremely essential to prepare your data, to clean your data at this stage. Then the next step could be visualizing your data. There are so many different kits that are available on Python that help you, visualize this data. There can be scatter plots, time series analysis. You could see trend lines, pie charts, bar charts, and so on to get an understanding of the data. You can also look at the overall distribution, and this could guide you as to which is the right model for you to use in this analysis. Once you visualize and get an idea, then you move on to your model's standard algorithms, sometimes designing them on your own, and you try and generate insights. Then you have to perform statistical tests. Now, what are these statistical tests? Basically saying that whatever findings you have, right? So you have to statistically validate them and basically supplement your argument with a certain statistical measure. So for example, let's say I was given the data of sales for the last 12 months. And now based on this, or for that matter, let's take it last 24 months, 2 years data. Now my team wants me to predict what is going to happen in the next 3 months, right? So I build a model and then I do my predictions. And then I statistically test if the numbers that I'm getting, how valid are they? So I can tell them that, with 95% accuracy, I am sure that the sales is going to hit XYZ figure. So this 95% accuracy, 98% accuracy, 99% accuracy. So these are the error of margins, and we're going to dive deep into the statistics and all of these measures in the models later. But yes, sometimes it is important for you. It's always a good practice to statistically validate your hypothesis and then back them up with good numbers before you present it to, the requesters or your customers. And then comes this consolidation via dashboard or a report. Now you might wonder, why consolidate your findings? You see, by the time, when we're studying in schools and colleges and we're reading about data science, let's say, we usually stop here, our problem stops here. But in reality, when you work with um, different customers, right, when you work with business teams, so as a data scientist, you or as a data analyst, you stand at the junction between the business teams and the research teams, right? So you're right there. Now, one of the key deliverables for you is going to be first conversion of a business problem into a mathematical problem. So that is extremely important. The ability to convert a business problem comprehensively into a mathematical problem, solve it, back it with statistics, and then reconvert your findings into insights that your business team can use. That is extremely important. And developing those communication skills, developing in and out, is something that takes time and of course varies from organization to organization. But that does lie at the fundamentals of your data science requirement. So yeah, that is all we have for today. If you like this session, please subscribe, and I wish that I get to see a lot of comments from you, and I'll be sharing um, my next video with you guys soon. Thank you.